This is part 2 of Springback analysis using Explicit Solver. Import part 1 file named contact.k file. Create nonlinear material using piecewise linear plasticity material card. Create material name using HSLA 340. Input true stress strain data as shown. Modify beam section shell card. Change number of through thickness integration points from 2 to 3. Update part beam material to HSLA 340. Open damping curve. Replace 1000 with 0. This will remove damping. Save file with name explicit only nonlinear. Run analysis. Check D3 plot file. As expected, without damping, the beam is in vibration mode after the load is removed. Check node out. The beam tip is vibrating after the load is removed. Now open the damping curve again. Change the damping value at 0.051 from 0 to 1000. Save the file with name damping nonlinear. Run analysis. Check D3 plot file. Now the beam tip is no longer vibrating. Check node out. The beam tip quickly moves to a stable position and keeps the position at a constant value. Check internal energy. The internal energy quickly reduces to a constant value which is in agreement with the beam tip displacement time history. Now let's set up seamless Springback analysis model. Delete damping card. This is implicit analysis, so we no longer need damping. Change termination time from 0.1 to 0.05. Because implicit analysis should start immediately when the load is removed. Create interface Springback seamless card. Create a part set for the card. Input 100 for NSHV. Create control implicit stabilization card. Since interface Springback seamless card will automatically turn it on. Create this card is to turn off the card by selecting 2 for IS. Create control implicit general card. Input 2 for in flag. This is required by interface Springback seamless. Input 1 to -3 for DT0 and 50 for NSBS. This will request the implicit analysis time to be 0.05 second. Create control implicit auto card. Input 1 to -6 for min and 0.01 for max. Now save the file using name seamless Springback. Run analysis. Check D3 plot file. As you can see, the Springback is much smaller than that of the previous explicit damping analysis. Check node out. The beam tip Springback displacement is very small. Check internal energy. The internal energy increases after Springback. This is absolutely not right. It looks like the seamless Springback analysis is not correct in this case. Now let's use conventional Dinan method. Output a Dinan file at time step 51, which is the time just before the load is removed. Now import this Dinan file. Create SBC for the beam. Create a node set which will be used in nodeout. Read a material with the name HSLA340. Input the true stress strain data. Create section shell card with thickness of 1 mm, input 3 for nip. Update the part material and section. Create implicit general card. Input 1 for in flag. 1 to -3 for DT0. 50 for NSBS. Create implicit auto card. Input 1 to -6 for DMIN. Input 0.01 for DMAX. Create termination card with termination time 0.05. Create database by checklstat and nodeout. Create D3 plot with output interval 1 to -3. Save the model using name Dinan method. Run analysis. Check D3 plot file. The Springback is much more than what we observed in seamless Springback analysis. Check no doubt. The beam tip displacement is much more than that obtained in seamless Springback analysis. Check the internal energy. Since the Springback analysis will treat all initial energy as zero. So what we see here is that the after Springback, the energy is decreased when compared with the initial energy.
Come, come, come. Well then, time to do labor.
Now output the Dinan file at the final step.
And do some labor.
Now open D3 plot file for damping nonlinear case. Output Dinan file at the final step. Now we import both Dinan files to compare the parts after Springback. As can be seen, the Springback part calculated by explicit solver is the same as the part calculated by implicit solver. This proves that explicit solver can be used for Springback analysis. This is the end of part 2. Welcome to subscribe CAE Training and Consulting. Thanks for watching.